Good evening. Once again, welcome to my YouTube channel. Now, today we'll be talking about a very important aspect of periodicity, that is how to determine the group and period of a certain element. We'll be using a very short and easy method, so follow us as we progress. Now, we have a diagram of a modern periodic table as proposed by Henry Moseley. Now, we should know that in the periodic table, we have horizontal rows which are called periods or series. Then we have vertical columns which are called groups or families. Now, the shortest period in the periodic table is the period 1, which has just 2 elements. Now, the longest period in the periodic table is period 6, which has 32 elements. Now, you might be wondering how. Now, check. We have lanthanum here, we have halfnum here. This guy is 57, 72. Now, in between lanthanum and halfnum, I have 14 elements, which makes up the lanthanide series. That's interesting. Now, we should know that period 4 and period 5 are of equal length. That is, they have 18 elements each. 18 elements each. So now let's forge ahead, let's progress. So we have excellent method used to determine the group and period of an element. So to find the period of an element, first of all, write the electronic configuration of the element. As such, the maximum value of n, which is the principal quantum number, should give you the period of the element. Now, to find the group of an element, if the element falls under the X block, electrons in NS should determine the group. If it falls under the P block, electrons in the NS plus electrons in the NP plus 10 should determine the group. If it falls under the D block, electrons in the NS plus electron in the D should determine the group. I will solve this, you will see it's very easy. Now, I will talk about the F block shortly. Now, let's take some questions to clear our mind. Now, we have our first question here. An element with atomic number 15 and mass number 31 is placed in, let's check for the group and the period. Now, firstly, we need to write the electronic configuration. So we have 15 for the atomic number. So we should write 1s2, 2s2, 2p6, 3s2, 3p3. Now the maximum n value is 3. 3, we have KLM. Now since it is 3, you should know that the period should be what? 3. Now let's determine the group. Now this guy fall under the P block. So let's fall back to our method. Now we said if the element is in the P block, number of electrons in our NS plus NP electrons plus 10 should give us the group. Now let's fall back and see if it will work. Now NS electron is what? 2. NP electron is what? 3. So 2 plus 3 plus 10 should give us what? 15. So we can say that this guy is found in group 15 or in group 5A. Bring your mind back to the periodic table. This is group 15 or group 5A. Very easy. Very easy. So what's our answer now? What's our answer now? Group 15, period 3. Option C. Very easy. Now let's take question 2. The general electronic configuration NS open bracket n minus 1 raised to the power 3 indicates that the particular element belongs to the group. So now we're looking for the group of the element. Now this element falls under which block? The D block. So how do we determine the group of this element? Now electrons in the NS is what? 2 plus electrons in the n-1d is what? 3. So automatically it is in what? Group 5. But we don't know which of the 5. Is it 5A or 5B? Now bring your mind back. It is in the D what? Block. So let's check. The D block. In the D block, we have the 5B, not the 5A. So the answer should be what? 5B. Option A. Very easy. Very easy. Now let's take one more example. Let's take one more example on the D block. Now you must have heard of this element. Titanium. Titanium is atomic number 22. Titanium. This calcium 20, 21, 22. So let's write the electron configuration. We have 1s2, 2s2, 2p6, 3x2, 3p6, 4s2, 3d2. Let's count. This 10, this 10, 20, this 22. Now to determine the period of titanium, we said the maximum value of n should give us the period. Now what's the maximum value of n here? 4. This is the maximum value. So titanium is in period 4. Period 4. Now what is the group of titanium? Now if you check, titanium falls under the D block. We said our formula is the nx electron is what? 2 plus the nx minus 1 d electron is what? 2. That will give us 4. That's group 4. So if you check, we have group 4. But you should know that it is what? Group 4b. Don't forget the D block 4b. Now if you check, here we have ns. Here we have ns minus 1. So it means that the n value for D, we can get it by nx minus 1. Now if here nx is 4, the n value for D will be nx minus 1. That is 4 minus 1. That should give us 3. That's the n value for D. Very easy. Now finally, we have a test yourself question here. An element with atomic number 20 will be placed in which group and period of the periodic table? So solve it, drop your answers in the comment section and we'll check. Now let's talk about the F block before we go. Now you know the F block, we have the 4F series and the 5F series. The 4F series are the lactanide, which are the 58 to 71 element. There is the cerium to the lutetium. Then we have the actinium, the 5F series. There is the thorium to the lawrencium, Lr. That is 90 to 103. So these guys, the lactinium, they are in the 6th period. Then the actinide and the 7th period. So we'll call it a day here. Don't forget to like, share and subscribe. God bless you. I'm Kubala.